Hello, students. This is your chemistry coach RR from Atomos Institute. So, today we are going to understand what is thermochemical equation and, of course, the different aspects of thermochemistry. So, what you will learn today through this presentation, that is what is thermochemical equations, conventions of thermochemical equation, SS law of constant heat summation, and of course, enthalpy of reaction in standard state is equal to enthalpy of formation product minus enthalpy of formation reactants in standard state. So this will be taken up in this session. So thermochemistry and thermochemical equations. So thermochemistry is the application of thermodynamical concepts in thermochemical equations. तो हम thermochemistry में thermochemical equations पर ही सारी एप्लीकेशंस करते हैं, तो हमें थर्मोकेमिकल इक्वेशन समझना बहुत जरूरी है. तो चलो देखते हैं क्या है. Thermochemical equation may or may not be the actual chemical reactions because there are certain conventions used while writing thermochemical equations. So thermochemical equations may or may not be the actual reaction. ये important point है. Actual chemical reaction और thermochemical equation में क्या difference है वो हम देखेंगे. और थर्मोडायनेमिक्स या थर्मोकेमिस्ट्री की जो पूरी अप्रोच है वो थर्मोकेमिकल इक्वेशंस को लेकर है. सो व्हाट इज थर्मोकेमिकल इक्वेशन? दिस इज अ बैलेंस्ड केमिकल रिएक्शन टुगेदर विद द वैल्यू ऑफ एंथैल्पी ऑफ रिएक्शन. हमें किसी भी केमिकल रिएक्शन को बैलेंस करना है, उसके फिजिकल स्टेट, रिएक्टेंट्स एंड प्रोडक्ट्स को मेंशन करना है, एंड वी हैव टू आल्सो राइट द एंथैल्पी चेंज ऑफ द रिएक्शन. व्हाट इज एंथैल्पी चेंज? बेसिकली इट्स एनर्जी चेंज ड्यूरिंग अ रिएक्शन. और अगर कोई आपका एलिमेंटल फॉर्म में सब्सटेंस है तो दैट एलिमेंटल फॉर्म मस्ट हैव द मोस्ट स्टेबल एलोट्रोपिक स्टेट. फॉर एग्जांपल, इफ आई टेक इथेनॉल reacts with oxygen, that is combustion of ethanol, to form carbon dioxide and water. You can see here I have taken 1 mole of ethanol. So in a combustion reaction we have to take 1 mole of the substance undergoing combustion. This is important because enthalpy value is enthalpy is expressed in kilojoule per mole, right? So इसलिए हमको इथेनॉल का कंबशन करेंगे तो हमें 1 मोल इथेनॉल जरूरी है. 1 मोल इज द इंपॉर्टेंट पॉइंट. कंबशन मींस एक्सेस सप्लाई ऑफ ऑक्सीजन एंड प्रोडक्ट्स आर CO2 एंड वाटर. Conventions used to write the thermochemical equation. What are the conventions? So the coefficients in a balanced thermochemical reactions never refer to the molecules. It is always mole because enthalpy has unit kilojoule per mole. तो जो भी आपकी स्टोइकियोमेट्रिक कोएफिशिएंट्स है वो किलोजूल पर मोल में एक्सप्रेस करेंगे, नंबर ऑफ मोल लेंगे, मॉलिक्यूल्स नहीं लेंगे. फर्स्ट पॉइंट. सेकंड, द न्यूमेरिकल वैल्यू ऑफ एंथैल्पी ऑफ रिएक्शन इन द स्टैंडर्ड स्टेट refers to the number of moles of the substance specified in an equation and having units kilojoule per mole. तो अगर हम किसी सब्सटेंस का कंबशन कर रहे हैं तो 1 मोल लेंगे, किसी सब्सटेंस का फॉर्मेशन कर रहे हैं तो 1 मोल लेंगे. तो ये हमें याद रखना बिकॉज एंथैल्पी हैज यूनिट 1 किलोजूल पर मोल. What is enthalpy of formation? The enthalpy of formation delta HF naught in standard state for a pure substance or most stable allotropic form at 298 Kelvin is the standard state is taken as 0. Elemental form या most stable allotropic form की enthalpy of formation by convention we take 0. For example, hydrogen H2 is the elemental form, so we take the enthalpy of formation value as 0. Again, carbon having most stable allotrop as graphite at 298 Kelvin temperature, so we take the enthalpy of formation of graphite as 0. Enthalpy of reaction can be expressed in terms of formation enthalpies as summation of product minus summation of reactant formation enthalpies. Next is enthalpies are extensive quantity. Extensive means the quantity that depends on the amount of substance. Amount of substance पर depend करने वाली properties को हम extensive कहते हैं और नहीं depend करने की properties हम बोलते हैं intensive. So enthalpies are extensive. So whatever the mathematical operations which we perform on the thermochemical reactions, addition, subtraction, multiplication, division, whatever, the same mathematical operations has to be performed on the enthalpy of reaction values, right? Hess's law of constant heat summation. What is Hess's law? So this is also the first law of thermodynamics. Hess's law is another statement of first law of thermodynamics. What Hess's law explains? It says that if a reaction is carried out in one step, let's say A to D, and energy change or enthalpy of reaction is delta H, then if we carry out the same reaction in different steps, let's say A to B, B to C, C to D, and enthalpies of respective steps are delta H1, delta H2, delta H3, then we can say whether or not reaction is carried out in single step or multiple step, enthalpies will remain same. That is, delta H must be equal to delta H1 plus delta H2 plus delta H3. So enthalpies of the respective steps, when we add together, we get the enthalpy of the overall reaction, because enthalpy is an state function. It does not depend on the path or process followed. So enthalpy is a state function. So this is another statement of first law of thermodynamics, which is conservation of energy. If a reaction takes place in several steps, then its standard reaction enthalpy delta H R naught is the sum of the standard enthalpies of the intermediate reactions, into which the overall reaction may be divided at the same temperature. In simpler way, we say enthalpy of a complex reaction means having multiple steps remains the same irrespective of the number of steps involved in the reaction, as given by the below diagram. So thank you all. Thank you for attention. I hope you must have understood what is basically thermochemical equation. That is, we have to write 1 mole for combustion, 1 mole for formation, since unit is kilojoule per mole. And stoichiometric coefficients are never molecules, they are the number of moles. So I hope you have enjoyed this lecture presentation. I'll be keep sharing, keep coming and providing you the error-free concepts in chemistry of class 11th, class 12th, NEET, JEE and foundation level 9th and 10th, so that आप अपने घर में बैठकर अपने ease को रखते हुए you can understand and learn chemistry in a very well manner without any disturbance and confusion. So all the best. मिलते हैं आपको अगले सेशन में. Till then, take care, keep learning. Bye bye.